In this video, I'm going to be covering question 2, part B from the 2019 AP Calculus AB Free Response Calculator Required portion of the test. I cover A, B, C, and D all in their own separate videos, so if you want to see those solutions, please check out my other videos. So looking at just B right now, B is asking us to use a trapezoidal sum with 3 subintervals, and they're telling us which 3 subintervals they want us to work with right here to approximate this integral. So the first thing that I do when I'm dealing with these types of problems and I've got a table of values is I generally pull the information off of the table and put it onto a number line. It's just going to kind of make deciphering the pieces you want a little bit easier to find. So this one's telling us specifically what intervals to label. So I would label my intervals. There's 0. This would be 0.3. Then from 0.3 we would go to 1.7. And then from 1.7, we would end it here at 2.8. And what I generally do is I come through and I kind of label that A1, A2, A3. There's my 3 subinterval areas that I need to calculate out. The next thing I do is I put the y values from the table that go with each of these different endpoints, because those are going to be important for us later on. So the y value that goes with 0 is happening here at 0. So I grab that value and I put that there. The y value that goes with 0.3 would be 55, so I put that there. The y value that goes with 1.7 is negative 29, so I put that there. And then the y value that goes with 2.8 is 55, and so I put that there. This problem isn't our standard Riemann sum where we would be using areas of rectangles. They're telling us that they want us to use a trapezoidal sum. So you need to know the area of a trapezoid formula. The area of a trapezoid formula is 1/2 base 1 plus base 2 times the height. When you think about it in terms of a picture of a trapezoid, what we're normally getting out here, this would be base 1, this would be base 2, and then your height is going to be that value there. But when we go to put this in terms of a graph, what you're really doing is you're kind of turning this trapezoid up on its side like this. And so this is base 1, this is base 2, and then the height is going to be right here. And what that kind of helps us see is that our bases, these are now going to be our actual y values off of our graph, off of our table. And that the h here is where you would normally see that change in x, that delta x. That's going to be our height. So that's how you want to be able to interpret this information as you come through and set these up. So now I go through what I just call the assembly line process. So I'm going to go A1 equals, A2 equals, A3 equals. And the first thing I do is just come through. Everybody's got a 1/2, 1/2, 1/2. And now I need to come in and put down what my base values are. So remember, the base on these are going to be the y values from these regions. So on A1, my base 1 would be 0, plus my base 2 is going to be 55. I then go to A2. On A2, my base 1 is going to be that left side. That's going to be 55, plus my base 2 is going to be the negative 29. Then on A3, my base 1 is going to be negative 29, and my base 2 is going to be 55. Now I want to come through and I need to multiply everything by the height. Remember, the height is going to be that delta x, that gap at the bottom here. So for A1, my delta x is 0.3. Notice that these are not standard, so they're different sizes for each one of these gaps. So from 0.3 to 1.7, that's 1.4. And from 1.7 to 2.8, that's going to be a delta x that's equal to 1.1. And so those are my heights. So on A1, the height would have been 0.3. On A2, the height would have been 1.4. And on A3, the height would have been 1.1. And now what we're going to do is we're just going to go find out what those actual values are. And lucky for us, this is a calculator required section. So I'm just going to open up my calculator and do it there. So I would get 1/2 0 plus 55 times 0.3, and that's going to get me 8.25. Then I'm going to go and do it for the next one. I get 1/2 parentheses 55, that's plus a minus, so minus 29, and then times 1.4. And that gets me 18.2. And then I do it one last time. I'm going to get 1/2 times negative 29 plus 55, and all of that times 1.1, and we get out of there 14.3. So then at the end, to get my total approximation, to get my answer, so I would do, the way I would put my answer is I would say the integral from 0 to 2.8 of v sub p of t dt is approximately, and then you just add up all these values, and that's going to give you what your final answer would be. So I would do 8.25 plus 18.2 plus 14.3, and then out of there I end up with 40.75. And so that would be our approximation for that integral using trapezoidal sums. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.